Good morning, everybody. It is 10 o'clock Central Time, and we are broadcasting live from the training department here at Door Controls USA in Ben Wheeler, Texas. Today's Top Tech Tips webinar is brought to you on behalf of How Do I Perform an Ohms Test on a DC Motor. I'm your host, Ben Calhoun. I'll be taking you through today's presentation. Make sure you go full screen mode, turn your sound up all the way, and don't forget about the Q&A box and the chat box down there at the bottom. After today's presentation, we'll sit down and have a little Q&A session with you guys, and we'll go from there. I can't wait to tell you more about this, so without further ado, let's learn everything we can about what is an ohm, what is a DC motor, and how do I do an ohms test. So here we go. All right, at first glance, things look a little complicated at this point. So we're talking all this talk about current and voltage and ohms and resistance and all of these things. And my buddy Eddie over here, he's kind of wondering in his mind what's going on. How's things working out on the electrical side of this? You know, my buddy's confused here. So in Eddie's mind, he's probably kind of processing things like this right here. So it's something like the square root of pi divided by r is equal to the circumference of a circle, but not of an equilateral triangle. True or false? And that's followed by a whole lot of wah, 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 wah. So let's make this a little simpler for you, right? It does not have to be that complicated. It does not have to be that complicated at all. In fact, it comes down to this right here. The omega symbol that you're looking at right there is what we refer to as ohms. And to keep this very simple, ohms is the amount of resistance that's measured between 2 points. So for example, if I have a piece of wire like this one, and I want to do an ohms test on this piece of wire, I'm going to measure this to see if it has any resistance from one end to the other. When you're doing an ohms test and you are measuring a piece of wire as such, you are looking for 0 ohms. So if I hook up a meter in a few minutes and I measure from here to here, it means it's going to give me a 0 ohms reading, and that means that there is no resistance between these 2 points, which is great for a piece of wire. Or if I'm measuring a fuse, same thing, 0 ohms is good, or a switch, 0 ohms across the contact of that switch is also very good. But there are some electrical components that need a certain amount of resistance or a certain amount of ohms values. And so we're going to hook those up. We're going to measure that. We're going to be focused specifically on a DC motor here in a few minutes. And let me show you a few things about that. So before we get to the motor part of this, we need to be able to measure ohms. We're going to use a meter like the one you see here. This is a very handy, easy to get a hold of meter. These meters right here are actually on our shelf right now, so if you would like to purchase one of these, you certainly can. Part number for that, as you see here, is a DC10273. Really great things about this meter here that I can tell you about. For one, the leads are very small, very fine point leads. This makes it very, very easy to get into some real tight fitting spaces. If you've got some very small connectors and you need to get in there and do some ohms readings, these leads are really, really nice to have. We also call this a pocket meter because when it's folded up, it will fit right in that shirt pocket or that back pocket or whatever pocket you want to put it in. It's handy, it's easy, doesn't take up a lot of space in the toolbox or the glove compartment in your vehicle. So very, very convenient to have. Also inside the lid here, we have this little pull-out sheet. I'm going to show you this in a few minutes, but this is a data chart for automatic doors specifically, and it's going to give you a lot of ohms values for many, many different motors. Also, this meter has the auto range feature, so when you turn it on, it auto ranges and it does what it's supposed to do. It tells you how many volts you're looking at. It's very, very handy and easy to use this meter. So again, I do highly recommend this meter. If you don't have one, this would be a great place to start. And if you do have a meter, this would still be a good, convenient, let's keep this as a pocket meter kind of thing. So let's get some of those. Now, when we use that meter, don't forget you are going to turn it on. And when you turn a meter on for the very first time, it's very important that I know this is a little bit hard to see for you guys here, but it's very important that when you turn it on, you select the continuity range, which is kind of looks like a little sine wave, or a sound wave rather, maybe a sideways Wi-Fi symbol. But find that on your meter, and then always touch your meter leads together. And when you do, you should hear that tone, and that signifies that I do have continuity between those 2 points. In other words, I have 0 ohms between these 2 test leads, which is perfect. And that's how you do a self-diagnostic test on your meter when you turn it on for the first time. So now you know your meter's in good shape. And we're going to be using that here in just a moment to measure a motor. On the next page here, I wanted to talk to you just real quick about that data chart. It is inserted in the lid of that meter. This data chart is readily available for you. We can send this to you. The tech support guys have these. You can get this on our website. You can also come to a quick start training class, and we'll also make sure you get one of these to carry home with you as well. And you can also purchase it when you do that meter. But on this data chart, there's lots and lots of different columns for you to see here, lots of information talking about things like activation and safety and breakout and stall and all these other features that are important for all these many different brands of doors. But today we're going to be focused on a DC motor and how many ohms should we have on that particular motor. So the motor we'll be ohming out today is an old Besom 300 Swingmaster. So at the very top of this side up here, if you look and follow that top line across, you can see that we're looking at about 13 ohms is what we're going to try to find today on the motor that I'm going to be measuring on the table here in just a few minutes. So this chart is extremely useful, and this is going to help you out a lot when it comes to how many ohms you should have on your DC motor. So here is the motor that we're going to be measuring today. It is an old school Besom Swingmaster 300 series motor, and we are going to get in there and we're going to take some ohms measurements. But before I really start measuring things with a meter, I'd like to spend just a minute of my time to explain what goes on inside this motor. So there are some components inside that once you understand what you're doing here with the ohms test, I think it'll make a little bit more sense. So check this out. Inside the motor, here's a graphic image of what we find inside. Up here above me is the armature part. You can also see that in the picture to my right over here. And on the armature, there's a piece just to the left of it, or to the right of it rather, called the commutator. The commutator is where the 2 spring-loaded motor brushes ride. And then the outside part of the motor, the shell or the case of the motor, is the where you're going to find the stator. And if you look up here at this picture, you can kind of see that inside a little bit better. The armature above, also labeled as the rotor. You have the rotor slots. Right up there you have the commutator itself. And if you follow the red and the black wires there, those are the brushes. And you can see how the brushes go against the commutator. When you energize those 2 brushes, it causes a field or a force that makes that rotor turn, and that's what powers up the DC motor. That's what makes it spin. So over time, those brushes do start to wear out. They're made out of a carbon material, and they start to wear down, much like the brake pads on your vehicle. The rotors on your wheels are turning, the brake pads are trying to slow them down, and it kind of it wears that pad off and builds up a sort of a charcoal looking surface. So we're going to look at some real live versions of this in just a minute. I just wanted you to kind of better understand what's happening inside that motor. So here are the real life pieces of what we will be looking at. So inside there, you can see what I just showed you in that picture. You have your armature and your commutator. It's kind of hard to see there at the bottom, but where the red and the black wire goes in, that's the commutator between the 2 brushes. And again, we're going to be taking this motor, we're not going to take the motor apart. Instead, we're going to do an ohms measurement on the motor. But I just wanted you to see what's actually inside there so that you can kind of get a better grasp upon what it is that you're taking a measurement of when you do an ohms reading. So just a few more slides here, and we're going to be doing that in real life. So here is the actual motor that we're going to be measuring. And you can see there just above us, we have a few pieces laying on the table. We have the DC motor brush, we've got the commutator and the armature and all that good stuff, and we're going to do an ohms test on this motor. First thing though, in order to do this, I've got to inject myself into that image so I can grab the meter leads and make it happen. So here we go. All right, I'm in. So right over here, we've got our DC motor that I was just discussing with you. And you can tell right away that this is a DC motor because we are looking at motor brushes right on the side of the body of the motor. The first thing you notice is what reminds me of maybe Frankenstein's neck, right? So you see those, those are external those are external motor brushes. And so that's a dead giveaway when I see this particular motor. This motor also happens to be a Besom 300 Swingmaster motor, so it's fairly common. There's a lot of Besom doors out there. This is just one that I happened to grab today so I could show you. And we're going to do an ohms test of this motor in just a minute. I'm going to grab my meter, I'm going to hook this up and show you properly how to do the ohms test. But real quick, I want to show you some of the key components. This piece right here is the motor brush that I was talking about, one of the two. There's one on either side, you see. So inside that cap, if you did open that up, you would find this motor brush right here. And this motor brush is made out of a carbon material. It's not all that different than the lead in a pencil, for example, or the carbon in the pencil. It's similar to that. And of course, it's a lot tougher and more rigid, but it's still like the brake pads on your vehicle. It rides along that commutator, and then it slowly wears down as the motor gets some more age on it. So let me slide that over here just a tad so I can show you maybe a little bit better picture of what I'm talking about. So inside the motor here, I'm turning the armature. Down there you do see the commutator, and then on either side you see where those spring-loaded motor, or those motor brushes, those spring-loaded motor brushes are located. Each one is connected to its own wire, so each brush has a wire. So the red wire goes through that brush, across that commutator, through the other brush, and out on the black wire on the other side. And when we hook up to do an ohms test in just a minute, that is exactly what we will be measuring. Basically from the tip of that red wire through all of that out to the tip of that black wire right there. And we're going to measure the amount of resistance that is in that circuit. So let me show you. This is an older commutator right here beside it. I'm trying to contrast these for you. So you see the new one on the right hand side of your screen, and you see the older one on the left hand side of your screen. So what I'm attempting to show you there is that charcoal looking surface that you see. That is a result of these brushes. As this motor turns, those brushes wear down and they build up that material that you see. Now, as that brush wears out and as that surface builds up and gets thicker and thicker, this motor slowly becomes weaker and weaker and weaker until it eventually hits a point where this motor will not work anymore because we have too much buildup. So when we're doing an ohms measurement, not only are we measuring just the circuit itself, but we're also checking to see what kind of layer of buildup that we have at that point right there. Okay, so that is how that works on the inside. Now, there is also inside the case of the motor, if you're curious to see what that part looks like, there are some large magnets. The magnets are what makes the motor possible. As you can see, when I went to stick that in there, it sticks pretty quick. The armature is arranged so that that armature is floating between the magnets, and then when you energize it, that magnet along with the voltage that you put in there is what makes the DC motor actually spin. So there's a few pieces like that. And then now it's time to show you how to do an actual ohms test on a DC motor. Alright, so I am going to set this motor right back over here. Kind of zoom in here so you can see it just a little bit better and see what's going on. The first and most important thing we need to do is identify the motor leads. On this particular motor, I'm going to be measuring between the black and the white wire. That's just this particular brand. A lot of DC motors out there are going to have a red and a black wire like you saw over there. That just signifies DC. But regardless of the color wire you have, just make sure you positive identify the motor leads. Once you do that, don't forget, turn your meter on to the ohms value. That is the omega symbol again. And we're going to hook up and do an ohms test on this motor. I'm going to try to position that where you can see the screen as I take the measurements. And remember, the chart we looked at earlier said we're supposed to have 13 ohms on this particular motor. So I'm going to hook up my meter leads. It does not matter which one goes to which. We're just doing an ohms test. And at that point right there, you can see that I do have 12 ohms measured between those 2 points. The sheet said we were looking for 13 ohms, so 12 is really, really close to that. There will always be a little bit of range, a little bit of tolerance involved, and that's okay. That's perfectly fine to see that we have 12 right there. It's actually a good thing. The next thing in real life that you're going to do, if your motor is installed in a door, you're going to grab the edge of the door, and you're going, if it's a slide door, you're going to slide that open a couple of inches and stop and take another reading. If it's a swing door, you're going to push it open a couple of inches, stop, and take another reading. As it is now, the motor is just here on the bench. So what I'm going to do is to turn the shaft of this motor. I'm just going to spin that shaft just a little bit. And that would do the same thing if I was sliding the door. It would force that shaft of that motor to turn. So what I'm looking for now, you see I have 12.2. I'm going to turn it a little bit more. And this time I've got 12.5, a little bit more. This time I got 12.2 again. I'm going to spin it some more. I got 12.4, 12.5. Notice each time the motor stops moving, I'm getting about the same reading in each and every spot, and that's good. That's a really good sign that I have a good DC motor right here. I'm attempting to identify a bad spot in the motor. So if I spin it a little bit and I get something like 48.2 or some real high number, well then that would tell me, or that would show me that I have a bad spot in that particular motor. But as it is now, this motor is ohming out at 12.5 just about every time that I stop and take a reading. So that is a good sign right there that we have a good motor. Now that is part of the ohms test. So the first thing you do, find the motor leads, hook up the meter, look for the amount of ohms you're supposed to have, and then spin it a couple of times or slide the door a couple of times. The next part of doing an ohms test is to go from each individual motor lead to the case of the motor. So I'm going to pick the black wire in this case, and then I'm going to the case of this motor or this operator. Notice on the screen of my meter, it does not change when I touch the case. It is showing me basically infinity, or rather there is no resistance being measured in this circuit right now at all. No readings are being taken, and that is a good thing. If I touch the case of this motor and one of the motor leads and I get something, then it's going to show me that the case or the motor itself has started to short out to the case of the operator, and that's not what we want. So we're going to check each wire again individually, and again in all cases make sure we don't see any amount of resistance or continuity or any type of measurement at all, and that is a good thing. So again, just in review, just one more time, when you get there, you need to do an ohms test. Make sure you kill the power on the circuit. You do not want the door to be up and running as you try to take these measurements, because that's really, really bad. Okay, so kill the power. Always unplug the motor. Identify the identify the motor leads that you're looking for. Make sure your meter is on ohms. And again, the first thing you do is hook up directly to those motor leads, and you look for the amount of ohms that you saw on that chart. We were supposed to get 13 on this motor. 12.5 is great. A little bit of tolerance there, anywhere from maybe 5 to 10% would be okay. Let me put it to you like this. If I'm measuring a motor and I'm getting 10 or 11 ohms when I should get 13, I'm not too worried about that. If I'm getting 14 or 15 ohms, maybe 16 ohms when I was supposed to get 13, that's still okay. That's still within that range. But if I'm turning that and all of a sudden I stop and I see something like 47 ohms, well, that's a dead clue that I have a real bad spot in that part of the motor. So I'm going to be real thorough. I'm going to move that door at least 6 or 8 times when I take that measurement. So move, stop, take a measurement, move, stop, take another measurement. And that's going to confirm that I have a good operating DC motor at this point. One more little trick of the trade tip kind of thing here to show you. If you have your motor unplugged and you happen to have my favorite tool in the world here, either a paper clip or just a piece of jumper wire like this. There are some other things you can do. Now, this is no substitute for the meter, obviously. The meter's very important. But if I was to, as it is right now, if I spin the shaft on this motor, it's super easy to turn. Very, very smooth, very easy. If I jump out these if I jump out these motor leads, as you can see right now, and I attempt to turn the shaft of that motor, it is a very difficult thing to do. It is an extremely hard to overcome that electronic brake that's created. So scientifically speaking, what happens in here, when I'm turning the armature or turning the shaft of this motor, I'm spinning that armature inside those magnets that I showed you earlier. That creates an electrified field, and that field is coming out of this motor. So essentially I'm creating voltage by turning the shaft of that motor, and I'm capturing that voltage right here with this jumper, and I'm sending it right back to where it came from. So I have effectively made an electric brake in this case. The faster you spin that, the more voltage it tries to create. So if you jumped out, the faster you turn it, the harder it gets to turn. And that's just another little step I can take just to kind of rule out, do I have a bad motor or not. It's just kind of a final assessment. But by all means, stick with the meter. If you're supposed to get 13 ohms and you measure 13 ohms, that's a good sign. You probably have a good motor. And of course, motor problems can go two ways. Your control has to give you enough voltage to power up the motor, and then your motor has to respond to that voltage. So you can always check the voltage coming out of the control box as well. If you have voltage coming out going to that motor, and that motor is not moving, well, that's a good sign that motor is bad. So guys, that's pretty much what all is involved with doing a DC motor ohms test. That's going to bring us back around here to the training department. All right, so we're back to the training department here at Door Controls USA. So again, this is a fantastic company to work for. I love being here. I love being a part of this program. Guys, I want to say thank you for sticking around and learning what you could about DC motors today from me. I hope it was informative. If you have any questions, we're getting ready to address those. So if you want to stick around for a Q&A, I'll be glad to do that for you. If you got to hit the road and you got to go back to work, I understand completely, and it's been a pleasure, and I'll see you next time. But guys, let's jump over to the Q&A session here. So here we are. I'm going to pull up a seat. I'm going to jump over here to the chat box on the Zoom here just to see if you guys put any questions. I'm pretty sure you did, so let's have a look, shall we? So right over here, I'm reading the chat menu, and I'm just looking for questions. So okay, somebody said that they joined us a little bit late in the meeting today and wanted to know if I can show that ohms chart one more time. Not a problem at all. I can go right back to that ohms chart in just a minute. Not a problem. And then let me check another question here. Okay, so what are some door? Here's another really great question. Somebody asked about what are some symptoms of a door that has a bad motor. What are the things I should look for when I get out there? So let me first back up to the ohms chart, and let me address that question first. So on the ohms chart here, on this data chart, these sheets on your left-hand side of your screen, you'll see the one for the sliding doors. So everything listed here is for slide doors. Over here on this side, we see everything listed for swing doors. And as you're looking at that, if you go across the column headings across the top up there, you can see where it says sliding, and then just beside it, it says activation. If you follow that activation column down, or that activation column rather, going down, and if you look, each one of these black lines you see is a different brand of operator. So on that page, you're looking at BSOM, you're looking at Door Controls USA, you're looking at Doormatic, Gyrotech, Record, King Monroe, Stanley, Tormax. So you see all of those, and then underneath each one of those headings, you see different line items, and those are the different series or different model numbers of that particular brand. So this chart is extremely useful. Not only are we using it for motor ohms, but we are also using it for activation, common, safety. This is a quick shortcut way. How do I hook up sensors? Where do I hook up my push plate? That sort of thing. So it's like having all of the schematics all in one place on one easy page, easy place to find page. Now, when you get a copy of that, you can print that out. You can keep it wherever you keep your meter. You can put it in the lid of your toolbox, or you can tape it to the lid of your or the roof of your service vehicle, or wherever it's handy for you. But by all means, guys, these charts are this is priceless information. Very, very useful right here. Speed up your time that way in the field. Okay, let me get back to the question menu here and see what else we may have. So, the other question, I'm sorry, about the symptoms of a door. So there's a few things to notice. Usually when you have a motor problem, it is usually so far gone that the door is just not operational at all. The motor part of this is really a high voltage component of the system. And it is DC power in most cases. At least 99% of all the motors we work on are going to be a DC motor. And so what happens there, when that motor does go out and it's bad, it usually just burns up that commutator, and those brushes just burn up to the point, or they charcoal up so much from wear that it's just going to quit altogether. Now, there is a little moment in time, though, where that kind of charcoal surface starts to build up and that ohms value starts to increase on the motor a little bit. So as the wear happens, as that motor, it's out there turning and building up surface like that, it does start to get a little bit weaker along the way. So it is possible you could walk up to a door and you could see it moves fine for a little bit through part of the cycle, and then it just kind of sluggishly moves. It kind of maybe even gets a little choppy as it tries to move. That might be something to look for. But generally speaking, though, if a motor's bad, it's really going to be bad, most likely. Now, if you have just a little bad spot in the motor, that can also have an effect. So you walk up to the door, you activate it, it moves a little bit, and then it kind of stops. Maybe if it's a slide door, it slides to a certain point and just dies. That could be a bad spot on that commutator where it just loses voltage. If you slide it just a little bit past that point and it takes off again, that also sort of confirms it. Also, guys, those charts, those are available, and we can send those to you guys in the email. I believe also where you registered for this webinar, when they sent that announcement out, it may also have had these attachments on that particular webinar. But if not, and you did not get those charts and you'd like to have those charts, super easy to do, not a problem. Just send us a quick email that says, hey, can I have these charts? And we will be glad to send that out to you. You can also, next time you talk to the guys in tech support, just tell them you need this data chart or this motor ohms chart. And again, that's not a problem to send that out. As well as you can find that on the website. So you go to our brand new Door Controls USA website, you go over to the tech support hub on that website, and you can find lots and lots of information like this, including all of these webinars, guys. So they are going to be posted for you. You do have to log in to get to them, but that information is there for you, and all the technicians out there at all these different service companies can access this. So we do want to be here for you and help you out with that. Let me do a quick check here and see if we have any additional questions that may have came in. I think I got that one, and I don't see any other Q&A questions at this point right here. So, guys, I just want to say one more time, I really enjoy doing these webinars with you. I really thank you guys for tuning in with us this morning and hanging out with me. It's always a lot of fun, and it's a pleasure hanging out with you guys and sharing what information we can about doors and door systems. If you have any questions that come up, if you think of something later that you just wanted an answer to, we're just a phone call away, or an email, or even a text. You can really get in touch with our tech support guys. You can also, again, check out our website and find information that way. But I just want to say one more time, I hope you guys are all doing well out there where you are. I know the world kind of went on pause for a little bit, but it is up and running again, at least trying to get that way. And that's going to keep you in high demand. And if you need parts, if you need help, if you need anything at all, reach out to us, and we're here for you. Guys, I'm going to go ahead and wrap this up. I'm going to shut things down right now. I just want to say one more time from the bottom of my heart, thank you, and thank you from Door Controls USA. We'll see you next time.